How you guys doing today? This is Mr. Muscarella coming at you, and we are going to take a look at solving trig equations review. Now the first problem we're going to take a look at says what are all the solutions to 5 sine x equals 3 sine x plus square root of 3. Now in the onset, people might look at this and get a little bit confused, but really all you're going to do is combine like terms. You're going to move this 3 sine x over. That is going to give you 2 sine x equals square root of 3. Solving for sine of x, you end up with square root of 3 over 2. Now you've got to think about this on the unit circle. And from the unit circle, you can kind of set it up using your reference triangles if you want, and you'll come up with these two pictures here. There's 2 spots in the 4 quadrants where sine is positive and returns a value of root 3 over 2. And one of those is at pi over 3, and the other one's at 2 pi over 3. Now, since this doesn't have any domain restrictions on it, it doesn't say from 0 to 2 pi, then that means we're going to go ahead and write it like this. We're going to take each one of those solutions, pi over 3 plus 2 pi k, k is an element of the set of integers, and 2 pi over 3 plus 2 pi k, where k is an element of the set of integers. So we're going to separate our two solutions this way. Now for question number 2, what are the solutions of 2 cos squared x plus cos x minus 1 equals 0 when theta is an element of 0 to 2 pi? So that means you're going to have solutions just in one revolution of the unit circle, but we're not going to include the very last spot, 2 pi. Now what we're going to do with this one, we're going to try a little bit different approach, and we're going to use a technique called u-substitution. And you'll do this a lot when you get to calculus, so maybe it's a good idea to start playing around with it now. First thing we're going to do is we're going to let u stand for cosine of x. When we do that, we're just going to be presented with this equation instead, 2u squared plus u minus 1. That's the same thing as 2 cos squared x plus cos x minus 1 equals 0, but we're making that u substitution. For a lot of people, they can see the factoring patterns a lot easier in this format compared to the original format of 2 cos squared x plus cos x minus 1 equals 0. From there, you simply factor. Setting each factor equal to 0 and then solving, you get a value of u equals 1/2 and u equals -1. Next, we're going to use a technique called back substitution. So we're going to take that value of u that we set, in this case cosine of x was the value of u, and we're going to put that back in for u. So that's going to give us cos x equals 1/2 and cos x equals -1. From here, you have to know those values on the unit circle between 0 and 2 pi for each one of those spots. For the first one, we end up with pi over 3 and 5 pi over 3. For cosine x equals -1, we just get x equals pi. Now usually you'll see those in most textbooks. They'll write them in order. So then your final answer would be x equals pi over 3, 5 pi over 3, and pi. Now if you saw how to factor that right off the bat, then you didn't need to use u substitution, and you could just go ahead and factor it to 2 cosine x minus 1, cosine x plus 1, set each factor equal to 0, and solve, and you would end up with the same 3 solutions. Either technique will work, and whichever one you choose, just make sure that your work is nice, neat, and organized. You want to keep your work like this so that it's easy for someone to read. All right, thanks for watching, and I'll see you guys again. Peace.